Okay, so question 4. A plastic strip is made in the shape shown. The curves AC and BD are both arcs of circles with center O. The larger circle has a radius of 30 millimeters and the smaller circle has a radius of 20 millimeters. The shaded ends of the shape are both semicircles. Okay, part A asks us to find out the area of ABDC, which is obviously this section here. If this is A, this is B, this is D, and this is C. So we want exactly this area. Okay, so to work this out, it's going to be, we're going to have to break it down once again and work it out. So those of you that know about sectors in a circle, you can identify there's a bigger sector here and there's a smaller sector here, and then you'll take the area of the smaller sector from the bigger sector. But those of you that are new to this, we're going to have a look at a circle. Normally, how we work out the area of a circle, it's, as we know, it's actually, area of a circle is pi r squared. Now, a sector is basically like a pizza slice of a, say for example, we want this slice and this angle in the middle is 60 degrees. We know that a full turn is obviously 360 degrees, so the remaining is going to be 300 degrees. So that's irrelevant right now. The 60 degrees is very relevant. We know that the full turn is 360 degrees, so if we wanted to find out the area of a circle, we use pi r squared, but we only want 60 degrees out of 360 degrees. So just keeping that information in mind, you can actually work out the area of this sector. So how we go about this is actually, the area of the circle is again pi r squared, but we also times this pi r squared by the degrees out of 360. So in this case it'll be 60 out of 360 degrees, and this will give us this sector area. So and bear in mind, this is actually the radius. So the radius is actually, in this situation, we're going to look at different radiuses to work out different calculations. Now, first of all, we've got a bigger sector area. Which I'm going to label here with a blue pen. Okay, so we've got a bigger sector area. It goes all the way till there, and this side as well. If we look, so that's the bigger sector. And first of all, to work out the area of the bigger sector, so we can call this area 1. The biggest sector will be area 1. So to work out the area of the biggest sector, it's just pi r squared times, again, the degrees out of 360. So which is 60 out of 360. If the radius is actually 30 millimeters, we're just going to input that into our formula, times 30 squared times 60 over 360. Put that in a calculator, we're going to get the answer straight away. So you do pi times 30 squared times 60 out of 360, and we should get 150 pi, which is actually 471.2 millimeters squared. Okay, so that's the area of the bigger sector. Now we will also want to work out the area of the smaller sector, which is, if you watch the red pen, it's going to be this point to that point and this point to that point. Okay, so that's going to be the smaller sector. Smaller sector, we're going to label it A2. We're going to label it A2 at the top here, and once again we're going to use a pi r squared times, what's that, pause it. No. Where's your notes, Krishna? So now, the area of the other sector, okay, so it's going to be pi times the radius squared, which is obviously 20 squared times 60 out of 360. We're going to once again put that in our calculator. It's going to be pi times 20 squared times 60 out of 360. It's going to be 209.4 millimeters squared. Okay, Now, obviously, to work out the area in between that red part, A, B, C, D, right? So to do that, we're gonna have to do A1 minus A2, so which is obviously going to be 471.2 minus 209.4, which is going to be 261.8 millimeters squared. Okay, so this is just part A. Okay, so part B. So part B, it says find the area of the two semicircular ends. Okay, first of all, if we got these two semicircular ends, which were shaded from before, okay, first of all, we need to find out what the diameter is, and with the information given, we can actually work out the diameter, because we know that the whole from here right to the last circumference is actually 30 millimeters, and the length here from the length here till the first circumference is going to be 20 millimeters. So the difference is obviously going to be 10. So this is 10 millimeters, right? If this is 10 millimeters, that's the diameter. So for example, if we want to work out area, first of all, to work out the area of a circle, okay, it's going to be pi r squared, as we know. Because it's a semicircle, we need to actually divide it by 2. Okay, so we need to divide our answer by 2. So it's actually pi r squared divided by 2. Okay, so now to work out that area, first of all, if we're given the diameter, if the diameter equals 10, then the radius should be 5. Okay, because two radiuses make one diameter. So therefore, if the radius is 5, we can look into this formula. Bear in mind, we've got two semicircles. If we've got two semicircles, if we put them together, we're going to get a full circle. So we can actually use the first formula, because we've got two semicircles, we're going to make one big circle. So we can just use, for the area, we can do pi r squared, which is actually pi times 5 squared. So you can actually got 25 pi, which is which is 78.5 millimeters squared.
Okay, so in this lesson, we're going to be doing question B. Find the area of the two semicircular ends.
Now, part C, it says find the perimeter of the complete shape. So what we're going to do is, where's the red pen?
I didn't have it. Explanation again, please, for God's sake.
Okay, so part C is to find the perimeter of the whole shape. So basically what we're going to do is work out, obviously, the length of this part of the circumference, this part, and then this part. Okay, so what we're going to do, first of all, we know that the circumference of the of both ends of the semicircle are going to be the same. So remember, first of all, to work out, bear in mind, if we put the two semicircles together, they're going to make a full circle. Okay, as you know, if you put them together, they're going to make a full circle. So based on that information, we can, if we work out the circumference of the whole circle, we're going to get the circumference of this side and that side, exactly what we want. Okay, so the circumference was actually pi times the diameter. The diameter being 10 millimeters. Okay, so circumference is pi times the diameter, which is 10, and that's going to be 10 pi, which is going to be 31.4 millimeters. Now we need to work out the circumference of this line. Okay, so how we're going to do this, the circumference of this sector. So if we put this sector into a whole circle, we're going to notice that it's going to look like this. It's going to be a 60 degrees there, and the only part we're interested is this part here. Okay, so to work that part of the circumference out, all we're going to do is again use the same formula. So circumference equals pi d, or circumference equals 2 pi r, because we're given the radius here. The radius of the smaller circle, as we know, is going to be 20 millimeters from 0 to this point here. So what we're going to do is, we know that this is going to be 20 millimeters, right? So the circumference is going to be 2 times pi times the radius, which is 20, but we're also going to times it by 60 over 360, because remember, we don't want the circumference over the whole thing, we only want it for this part. So we're timesing by 60 over 360. So therefore we're going to get, put that in the calculator, we're going to get we're going to get 20.9 millimeters. Okay, so that's just for the smaller circumference, and also we're going to do the same thing but for the bigger circumference. So we're going to have, once again, 60 degrees here, but this time we're going to use the bigger radius. We're going to use the bigger radius, which is going to be 30 millimeters. It's 30 millimeters, and if you put this back into the formula, so we get 2 times pi times 30 times 60 over 360, right? This is going to give us the circumference of this part. Okay, exactly what we need. So we put that in a calculator, and all we can do is, on our calculator, just change the 30 to so the 20 to a 30, and we should get 31.4 millimeters. Not sure why I've put a square there by accident. Now what we're going to do is we're actually going to add all these answers up together. So if we add them, we're going to get, so if you add all the perimeters, is going to be 31.4 plus 31.4 plus 20.9, it's going to be 83.7 millimeters. That is going to be the perimeter for the whole shape. Thank you.
Thank you for.
So for this question, we're going to be doing 4C. This question, we are going to be doing 4C. Find the perimeter of the complete shape. We're on question 5 now. A washing powder ball looks from the side like a circle with a shaded area removed. The circle has the radius 5 cm and the angle AOB 80 degrees. Question A. Find the area of the sector OAB.
Question 5. Question 5 asks us to work out the area of OAB. So follow from O to A to B. So we want to find out the area of this sector. So first of all, to work out the area of the sector, we need to remember that, okay, once again, so to work out an area of a circle, it was actually pi r squared, but because we're only working out a sector, working out just a small part of the circle, so what we're going to use is pi r squared. We're also going to multiply it by 80 out of 360, because that's the part of the sector we're actually going to be using. So to work out the area of the sector, what we're going to do is the area is going to be pi r squared, the radius being 5, so it's going to be pi times 5 squared times 80 over 360. I put that in a calculator. It's going to be pi times 5 squared times 80 out of 360, and we're going to get the area of 17.5 centimeters. Okay, so that's centimeters squared. And part B, they ask us to find the area of the triangle. Okay, to find out the area of the triangle, if we know that this side the radius is 5 centimeters. We know the other side is 5 centimeters, and because it's not a round triangle, we can actually use the formula to work out the area of the circle, which is a half AB sin C, which is actually going to be a half times 5 times 5 times sine of 80 degrees, and if we put that in a calculator, we should get 25 divided by 2 times sine of 80 degrees, which is actually going to be 12.3 centimeters. Okay, squared. So now we've worked out the area of the triangle, and we've also got the area of the sector. So if we've got the area of the sector, and we've got the area of the triangle, to find out the area of the shaded area, what we're going to do is to find out the shaded area, you're going to do the area of the sector, take away the area of the triangle, which is going to be 17.5 minus 12.3. So 17.5 minus 12.3 is going to be 5.2 centimeters squared. That's going to give you the remaining part. Done. Thank you very much.